Dr. John Pomeroy, a snow scientist with the National Hydrology Research Centre in Saskatchewan. In 1993, the centre became a partner in the Prince Albert Model Forest Project. The snowman, Dr. Pomeroy, and his team were to study the forest's unique ability to survive on its own, to be able to control its own water supply, restore nutrients to its soil, and even keep an eye on its own thermostat.
Well, there are various mechanisms by which it controls its climate. In the winter, for instance, the trees intercept snow. They capture about a third of the snow which falls, and this evaporates out. And this happens in a spruce forest or a conifer forest. In aspen forest areas will not capture this snow. This regulates the amount of snow available in the springtime and the stream flow conditions.
Hauling the scientific equipment behind him, Newell Hedstrom, a former Olympic athlete, is putting his skills to good use as a key member of the team.
What we're really trying to do is a budget, much like a financial budget, but in this case it's a budget of energy and water. And so we look at the energy coming into the system from the atmosphere, solar radiation, warm winds which blow down into the forest, and we also look at what's moving out of the forest. We look at what's entering the soil and moving out of the soil.
Every little disturbance in the life of the forest is watched and measured by the snowman and his team of scientists. The sun's warmth, the volume of water, the amount of rain, and the depth of the snow. In one study, they weighed the snow that fell on a suspended jack pine tree.
That's a weight in grams.
We were rather surprised with some of the results we had. Our jack pine tree accumulated 33 kilograms of snow, a single tree. And of that snow, only 9 kilograms ever made it to the ground. The rest evaporated back up into the atmosphere. So this is several things. One is a very important source of water vapor in midwinter in the center of the continent, and otherwise a very dry atmosphere. The second thing is that under the trees you'll find a very shallow snowpack. This melts out very early, and so the ground there becomes snow-free first. And this gives these conifers a little bit of an advantage in the springtime. The aspen trees won't have this advantage. The snowpack that you see in the profile, the snow crystals there are completely reformed from what fell initially. And this is because of the heat release from the soil modifies the snow over the winter.
Well, I think we have probably three layers with the last week of warm temperature. Most of the middle layer here has gone quite uniform, with the size of the crystals in the profile getting much larger as we get to this coarse hoar right at the bottom layer. This crust of about 2 or 3 centimeters has been created on the surface. The particles that are probably the most interesting are that are right at the very bottom, where we get to see some columnar crystals. Yeah, here's a good example of some needle crystal just right off the end there.
Now what happens over the winter, the snow sitting in the canopy and on the ground acts as a filter, and it picks up nutrients, particularly nitrogen, from the atmosphere. When melt occurs, the chemicals have moved from the inside of the snow crystals to the outside. That's the first bit that melts, and that's where the chemicals and nutrients flush immediately down to the snowpack. So you have 6 months of storage, maybe 3 or 4 days of release directly into the soil, and the first water that enters the soil has the most nutrients. So that's a very important thing, because it's relatively warm and it's rich. Then in the spring, it's the first sign of life in the forest as things wake up occurs actually in the snowpack. So the snow begins to melt, the water flows down in fingers down into the ground. As soon as this very nutrient-rich water hits the soil, small snow algae wake up from a dormant life form and swim up the flow fingers up to the upper part of the pack where there's a fair bit of sunlight. They then bloom into algae blooms, which are then fed upon by other small microorganisms, and eventually up to snow fleas, which you can see in the pack. These are captured by snow spiders. It all dies, and the snow mold begins to consume it. So you have a complete life cycle occurring in the pack, really before anything else wakes up in the forest. Why it's really critical is that this gives a kickstart to the whole ecosystem in the spring. It provides initial food source for everything else as the plants under it begin to wake up and the other animals become active. This is a very important time in the streams. This is when the fish spawn. This is when a lot of the small aquatic wildlife comes to life and begins to reproduce and things like this. So it's tremendously important. There's a lot of energy, water, nutrients rushing through the landscape right now.
For more information, visit our website on topoftheworld.net.